Welcome to the second video lecture for the second week of the MPP math course. This will be a quick lecture about absolute values. Absolute value notation is something that you've probably been seeing for a long time, just two vertical lines, which suggest that if x is less than 0, you negate the negative sign. You can also think of that as multiplying the value of x by -1, which would remove the negative value. This is probably the second expression is probably more like what you'll see in class. It's just to remind you that if you have a full expression inside of the absolute value signs, you need to distribute the -1 across the full expression. In truth, where absolute value gets a little bit tricky is where you have a algebraic expression. So basically what ends up happening is you have two possible cases. You could think of it this way, that you need to take a -1 and distribute it across, and so there's either a negative value or a positive value of the expression on the left-hand side. It's equivalent to think of the negative solution to the absolute value being a negative sign on the other term on the right-hand side of the equation rather than the left-hand side of the equation. What that means is that you usually have two cases for the solution, and so you'll end up having two different solutions. Take a moment right now. You probably did a bunch of these in math camp. Just refresh your memory of how to do the problems. Pause the video, and I'll come back in a moment with the solutions. So go ahead, check your work, pause the video again if you need to work through anything or if you're not sure how I got any of the solutions that I got. The place where absolute value gets really tricky is if you have more than one expression, because what ends up happening is you have to take the full number line and break it into different cases. So in this case we have two expressions, and what we need to do is consider where do the expressions in absolute value change sign, and then do three separate cases, one for each of the different combinations of sign change. So if you look at the left-hand side, x minus 3 changes sign when x equals 3. And the expression on the right-hand side, 3x plus 2, changes sign where x equals -2/3. As a result, we then have three intervals we're going to consider. One where x is less than -2/3, one where x is between -2/3 and 3, and one where x is greater than 3. So to do the first, the absolute value on the left-hand side is negative under this condition, and so we need to take a -1 and distribute it across that expression, so we get -x plus 3. Similarly, the second absolute value is also negative under this condition, and so we distribute a -1 across it so that we get -3x minus 2. From that point, it's just a matter of algebra to go ahead and solve the equation for its solution. We repeat the process for the second interval. For the second interval, the left-hand absolute value is still negative, so we distribute a -1, we get -x plus 3. The right-hand absolute value is positive, so we don't need to do anything to it. And at this point, we have a straightforward algebraic expression that we can work through the algebra to solve. The third solution is both absolute values are positive, so we can simply remove the absolute value signs without doing anything and solve algebraically. But this last case points out something very, very important. If you look at the different solutions we came up with, we had -3 on the interval between -∞ and -2/3. That's fine. We had 1/2 between -2/3 and 3. That's fine. However, between 3 and infinity, our solution was x equals -1, which is a contradiction with the case that we set up in the very first place. So that solution, after we've solved for it, falls away. Take a moment right now. If you look at the bottom right on the slide, you'll see two arrows faced head to head. That's just another piece of math notation that sometimes you'll see professors use. It means contradiction. So we had a contradiction between our solution and the interval for the case that we set up, so that that is not a valid solution, and there are only two valid solutions to this absolute value equation, x equals -3 and x equals 1/2. As you can imagine, these kinds of problems are not always the most straightforward. So take a moment right now, pause the video as you need to, work through this practice problem. And here we go. We break it into 3 intervals, one between negative infinity and 2, one between 2 and 8, one between 8 and positive infinity, and notice that one of our 3 solutions was not a valid solution, so that there are only 2 solutions here, x equals 3 and x equals negative 11/3. And that's it.